So in this video, we'll continue our discussion on trigonometric integrals, where the integral contains the product of two functions sin x and cosine x. And the fact is that both sin x and cosine x has got certain exponents. And in the last video, we looked at the case where either one of the m and n is odd. And so the remaining cases we have not discussed in the last video is about this case where both m and n are even now. And I claim that the method is completely different. So you have to make use of certain trigonometric identities. So let me put it there. And some people call it the half angle formulas. So the fact is that cosine square x actually is the same as 1 plus cosine of 2x divided by 2. And similarly, sine square x is the same as 1 minus cosine of 2x divided by 2. So and we have to make use of these identities. Let's see how to do it. And please look at the key. The key of these two half angle formulas is that you can make the trigonometric function which originally has a power 2 to something which is a expression on the right hand side where the power is actually changed, right? So the power becomes 1 here. Moreover, in that case, the angle is actually doubled, you see, from the left hand side to the right hand side. That's the two key things about these two formulas. And anyway, let's look at an example now. Let's look at how we integrate this one, where we have the cosine square x inside the integral. You see, we cannot use the last trick of the method of substitution in the last video because the power is not odd now. So our method is not working. And instead of using the u substitution, I claim that we actually make use of the half angle formulas here. So the next step is going to be 1 plus cosine of 2x at the top divided by 2, the whole thing dx, right? And of course, this divided by 2 is actually a common factor 1 over 2 for the two terms on the top of the numerator. So I can pull out the constant like this. And to integrate this is actually not that difficult because it becomes x plus, and you are integrating cosine of 2x. So it becomes sine of 2x because integration of cosine x becomes sine x. But because of the fact that you have a 2 attached to x, we have to divide it by 2. And the whole thing, we can add the constant at the end. So it is the final answer to this problem. And please look at the key. The key, as I said, in this problem is that originally this power is even, but by the use of this formula, first, the angle is doubled. Second, the power, you see the power is reduced to the power 1. And when you're integrating a trigonometric function with power 1 for the cosine function, you can write the answer down pretty easily, right? And that's the key here. These kind of formulas allow us to change the power. So let's look at one more example. So let's look at the current example, which is the integration for sine x and the whole thing to the power 4. And I claim that you still have to make use of this formula. And the fact is that we just need to apply it to the whole thing because now sine x to the power 4 is the same as sine square x, the whole thing square, right? So it means that I can apply this formula for sine square x, which is 1 minus cosine of 2x, the whole thing divided by 2. And we will take the square because of this. So we have to extend algebraically. And please note that this kind of factor 1 over 2 because essentially you're looking at this. Please look at the right hand side we have now. So we can pull out this 1 over 2 times 1 over 2 because of the square in front. So we have 1 over 4 and the whole thing integral, which is 1 minus cosine of 2x, the whole thing square, right? And we can do algebra to expand it. So the inside becomes 1 minus 2 times cosine of 2x plus cosine square of 2x. So please note that I'm kind of expanding it by the use of this algebra because the algebraic identity is that a square minus 2ab plus b square. Anyway, let's do the integration now for the latest step, term by term. So let's look at it this way. The first term is gonna be x because you're integrating 1. The second term becomes what? The second term becomes minus 2 times sine of x because cosine becomes sine for integrations, and we have to divide it by 2 because of the 2 attached to x, right? And this is the integral for the first two terms, 1 and 2. But the next term we have to be slightly careful. The next term is that we have to deal with the integration of cosine square of 2x at the end. So you see I'm splitting the last one out of the first two integrals because the last one there's still more step to do. And please look at this fact now. You see the power is even, right? So it means we can stick with our approach. Whenever the power is even for the trigonometric function inside the integral, we can make use of the half angle formula. So for example, let me write down the answer now. So by the use of the half angle formula, the integral now becomes the equation of 1 plus cosine of 4x divided by 2, right? Dx. And now you see the angle must be doubled every time you apply this formula. And you see now the power, which is originally even, becomes odd, which is 1 now. And we're able to, of course, integrate this. Let me write down the next couple of steps. So you see in the next step, what I'm doing is I pull out this common factor 1 over 2 for the big fraction inside. So now it becomes 1 over 8. And the last thing that you need to do is you have to integrate what you have inside the integral. So 1 becomes x here. And cosine becomes sine, right? And the sine of 4x divided by 4 inside. And essentially, that's the final answer to this problem. Of course, you can write it in a better way because you can actually bring these two terms together. Both terms has the x term. But anyway, it's the final answer to this problem.